In the previous episode, the students found the hour at which Harry's peanut butter sandwich had 200 grams of mold. In this episode, they find the amount of time it takes for the amount of mold on Harry's peanut butter sandwich to increase by a factor of 20.
So we know that the growth factor is 4, so I guess that will be on the bottom. And the other side on the equal side will be the answer of the exponent thingy, so that would be the x, right? We're trying to get x.
Can you explain what you've done?
Well,
Yeah,
the 4 is the growth factor per hour. The x is what we're trying to find, and then this is the number of grams of mold on that hour x.
Okay, and you've said that so what is x? You said that was the thing you were trying to find. What is it in the context?
It is the number of hours passed.
Number of hours passed. Okay.
Wait. I didn't get that right, did I?
What do you think, Josh?
I did not get that right again.
I think you've come to an important realization, which is that this equation is not quite right.
Well, we know that the x should be what we're wanting to get, but this, we know we got this part wrong. So we need to figure out what that is. Just erasing the x too so that it's like more clean. Equals x. Well, what is that x anyway? So we don't have an hour on the x. So we have an hour passed on the x. And over that hour, there's a factor 20, which we can use. Nice. This makes sense because if you started at like 0, you get 1. Then you would end at hour x. And you would have 20. So 20 would be still the number on top of x. But here, we don't have an hour x. We just have a factor. But on both of them, you have a factor. You can still use a factor.
Josh and Arobindo are trying to find out how long it takes for the amount of mold on Harry's peanut butter sandwich to increase by a factor of 20, which they call x. Their number line illustrates one place this increase happens. It shows that from hour 100 to hour 100 plus x, the amount of mold increases by a factor of 20. Originally, Arobindo thought x was equal to log base 4 of 4 to the 100 times 20. However, they eventually decided that this was incorrect. Arobindo correctly explained that this logarithmic expression would represent the hour at which the peanut butter sandwich would have grown 4 to the 100 times 20 grams of mold. But this wasn't the x they were looking for. They were not looking for an hour at which there was a certain amount of mold. They were looking for the number of hours it took for the amount of mold to increase by a certain factor. He needed to adjust his expression, which he did. He correctly changed it to log base 4 of 20 equals x. He explained that this represents the amount of time it takes for the amount of mold to increase by a factor of 20.
So what is this starting at 0 and ending at x, going from 1 to 20? What does that have to do with this picture here?
Well, earlier you were using like the number that was on top of the x, but here we don't have any number on top of the x. But on both of them we see they have like this growth factor over like x hours.
Mm-hmm.
So we can use that growth factor.
So what is the growth factor over x hours?
In this case it is 20.
And in general, what is if we didn't know what x hours?
Well, it would be this number. What? Oh yeah, you had the mouse. This number divided by this number over this many hours.
Can you write an expression for the growth factor over x hours without knowing x?
At this point, the students have explained using a number line that log base 4 of 20 gives the amount of time it takes for the amount of mold to increase by a factor of 20. The students will now explain in general, using p as a starting time, how that logarithm helps them find the amount of time it takes the mold to increase by a factor of 20.
Okay, can you write in how much time has passed and what factor things are increasing by?
This is times 20. And then times 20.
And then how much time is passing here?
X.
Okay.
I'm trying to find.
Can we write that times 20 in a different way? So we have times 20. Can you tell me about the times 4 to the x?
That's the same as 20.
How do you know you can write it as 4 to the x?
Because there's x hours, and then there's 4 per hour. So, well, we could just draw it in here. P plus 1, here, 4. So you see that it goes up by 4 an hour, and there's x of them, so then it goes 4 each hour, so they're multiplying 4x times.
Okay, so now can we write a logarithmic expression that tells us what x is?
Yeah, just log. And so we know the factor is 4, so that's what we had on the bottom. And we're trying to get x. And we have, this is 20.
Why does 20 go there?
It's the factor. You could also write 4 to the x there, but that doesn't really do anything because you just know that because 4 to the x is equal to 4 to the x.
Okay. Yeah, so we said log base 4 of 20 is an exponent. What exponent is it? So how are these two things related? This 4 to the x equals 20 and the log base 4 of 20?
Their x's are the same. And of course the numbers are the same because 4 is 4 and 4 is the same as 2.
Okay.
In this lesson, Josh and Arobindo used both interpretations of logarithms to solve different types of problems in the moldy food context. First, they explained how log base 3 of 10 could represent the hour at which the pizza, whose amount of mold tripled each hour, would have 10 grams of mold. Next, they explained how log base 3 of 10 could also represent the amount of time it took for the amount of mold on the pizza to increase by a factor of 10. In the last 2 episodes, Josh and Arobindo again demonstrated that logarithmic expressions could be used to express these two types of quantities. They explained how log base 4 of 200 could represent the hour at which a moldy peanut butter sandwich, whose amount of mold increased by a factor of 4 each hour, had 200 grams of mold. And how log base 4 of 20 could represent the amount of time it takes the amount of mold on a peanut butter sandwich to increase by a factor of 20. In the next lesson, the students will use their contextual understanding of logarithmic expressions to explain why two expressions are equal to each other.